All right, this is Chapter 5, Lesson 2. I'll be doing the guided practice off of page 360. I'm also going to be trying to relate this back to Chapter 1 when we were going over constant rate of change. All right, so we're looking at sequencing, which means we have a pattern in numbers, especially arithmetic sequence, which means you're adding the same amount each time. So let me just do a couple of these, and then I'll try to relate it back to, like I said, constant rate of change. So if I look at this, 0 to 9 to 18 to 27, we're looking at, it's pretty obvious, I'm adding 9 each time, right? So you could go ahead and you could just add 9 and continue getting 36, right? You could add 9 again, get 45. You could add 9 again, get 54. And you could continue this on forever, and that's fine. If you wanted to talk about what the rule was, it's add 9 to the previous term, right? Remember, each number in the sequence is called a term. In fact, I like to relate what term it is. The first term was 0, the second term is 9, the third term, the fourth term, the fifth term, the sixth term, the seventh term, and then I'm going to even write one for the what we used to call the nth term, which means I'm going to use a variable, which means I'm going to write one that will work for anything. All right, so here's how I would do that. Once I realize I'm adding 9 each time, this is a lot like doing constant rate of change. Every time this goes up 1, this goes up by 9. Every time this goes up by 1, this goes up by 9. We can do that by subtracting difference of y over difference of x. We've talked about that. So when I put those together, I'm going to put that as a slope of 9. That's the constant rate of change. Every time this one's changing 1, this one's changing by 9. You might even remember this. Y equals 9x. If it's proportional, we'd be done. My question is it proportional? Well, here's how we could check it. If I continued this on down, let me go backwards 1. So if I were going this way, I'd be subtracting 9 each time, right? So 0 minus 9 is negative 9. It's going to hit at 0, negative 9. Where would it have to hit to be proportional? 0, 0. By the way, this right here is that adjustment. So there, y equals 9x minus 9, right? So if I want the nth term, I would just need to take whatever number's up on the top. I need to take it times 9, subtract 9. So I could find the 100th term if I wanted. The 100th term would be 900 minus 9, which would be 891. Notice, that should look familiar. We've done constant rate of change. We found out it was not proportional, so it's not your mama's ex. It's your mama's ex-boyfriend. And now we have a way of finding that boyfriend. We could even graph that thing if we wanted to. It would look like this. It's going to hit at negative 9. It's going to be going in a constant rate of change. Sorry, you can't see what I'm doing there. It's going to go hit at negative 9. It's going to go at a constant rate of change of up 9, right 1, up 9, right 1. Notice it does not hit at 0, 0, but we could still graph it. It is not proportional. All right, so let's try another one of those. Second one, 4, 9, 14, 19. You can find that out pretty quickly that we're adding 5 each time. So if you're going to write the rule, it's add 5 to the previous term. You could continue that out. That would be 24. That would be 29, 34. And then I'm going to remind you that we can do this first term, second term, third term, fourth term. And I'm looking for a way of getting from here to here. Okay, well, remember, difference of 1, difference of 5, difference of 1, difference of 5. You're probably getting the pattern that we were adding 9. Now we're adding 5 every time. Guess what? That's going to be y equals 5x. If it's proportional, we'll be done. If it's not proportional, how do we check for proportional? Yeah, you can go 1 extra down. Now I'm subtracting 5, right? Minus 5, minus 5, minus 5 would be negative 1. It hits at negative 1. Do you see it's not proportional? So that negative 1 is what goes right there. That's the adjustment that's made. Remember the y-intercept of negative 1. So I could graph that again. Remember, not proportional, so it's your mama's ex-boyfriend. Hits at negative 1. It then goes up 5, right 1, up 5, right 1. Once again, not proportional because it does not hit 0, 0. And we've got that kind of figured out. Let's go with one more. 1, 1.1, 1.2, 1.3 is still an arithmetic sequence because it's going up the same amount each time. It's going up by 0.1 each time. That would be your way of finding your rule. It's adding 0.1 to the previous term every time, so it's just going to be 1.4, 1.5, 1.6. We could go, say that was the first term, the second term, the third term. We could back one up, eventually go to the 0 term because that's going to be an important one. This is our adjustment. Notice that was your adjustment. That 0, -9 was your adjustment. That was your adjustment. This one right here will be our adjustment when we do it. Okay, so constant rate of change, it went up by 1. It went up by 0.1. Went up by 1. It went up by 0.1. All right, so let me write that down. That's y equals 0.1 times x. So let me go back down 0.1 to go backwards, because we're going down 0.1, down 0.1. I'd be at 0.9. All right, so I would have to add 0.9. Let's just take one to make sure it works out. Let's just try 3. 3 times 0.1 would be 0.3, and 0.3 plus 0.9 is 1.2. Did it work? Let me even skip out here to the 5th one. Let's try the 5th one. All right, so 1.1 times 5 would be 0.5 times plus 0.9 is 1.4. It works every single time. So if I wanted the nth term, I could write that as whatever n is, take it times 0.1, add 0.9, and you'll have the number underneath it. So could I find the 1,000th term, or the 4,000th term, or the 30,000th term? Sure. Just plug it in, solve it. Okay? All right, so number 4 says Hannah has a doll collection. The table shows the number of dolls in her collection for 3 years. Suppose the pattern continues. Write an algebraic expression to find the number of dolls in her collection after n years. How many dolls will Hannah have after 25 years? All right, so here's what we look at. It's going up by 6 every time, right? So up by 6 every time it goes up by 1. Up by 1, up by 6. I could write that as 6 times n. We should check to see if it's proportional. Once again, could we back it up and go back to 0? Once again, if I'm going up 6 going down this thing, then when I reverse it, I'd be subtracting 6, and 6 minus 6 is 0. Do you see that proportional point? 0, 0. That means this is your mama's x, right? It's proportional. So if you divide it, 6 divided by 1 is 6, 12 divided by 2 is 6, 18 divided by 3 is 6, and 6 is your constant of proportionality.